AVIA3401 777-200ER carrying 307 passengers crashed in San Francisco in July 2013. 3 died after descent below the visual glide path resulted in stall conditions crash into seawall. Automation was cited as a major contributing factor in specific lack of understanding of the auto throttle system.
AVIA3401 wind 350 degrees, 10 knots, runway 28 left, clear to land.
Clear to land, 28 left, AVIA3401.
Altitude, sir, we are hopping. Speed low, sir, sync rate.
Disengage autopilot, flight level change.
Controlled, sir.
Warning speed and power.
Speed checked.
Speed low, go around.
Stake shaker, approaching stall. Oh, we crashed!
Automation changes the pilot's active involvement in operating the aircraft into a monitoring role. This can lead to a reliance. Basic manual flying skills can decline because of lack of practice. This is exacerbated if operators actively discourage flight crew from manual flying. Pilots who invariably fly with auto throttle engaged can quickly lose the habit of scanning speed indications.
The bow tie model tells us that if hazards are not controlled, they have the potential to cause detrimental effects on unforeseen situations. Automation reduces the workload for procedures that are less complicated, such as cruise face-off flights, but it adds more workload on heavier procedures such as approaching and departure. The complex system overloads pilots' cognitive memory. Automation also prevents pilots from understanding the theories behind the system, posing a risk of making inaccurate decisions during an emergency. Pilots lose confidence in automation when constant false alarms occur, which results in pilots ignoring and deactivating the system. Over-reliance on automation creates boredom in monotonous environments. It could also lead to de-skilling, where pilots easily miss out on critical procedures and lose cognitive skills. Without proper and adequate training to educate the pilots, these could all lead to a loss of situation awareness, which is exactly what caused the Asiana accident in San Francisco.
The aim of automation is to reduce pilot workload and ensure a safe flight. However, there are chances of error occur. This may be due to emergency, general confusion with the autopilot system, or lack of training. It is important in both single and multi-crew operation. Multi-crew allow pilots to cross-check each other's input, this sort of providing an extra layer of defense with according to recent sweet cheese model. For single pilot operation, they are relied on pilot themselves. It's totally mentioned that automation is part of the crew member, therefore pilot needs to comprehend it well. American Air Flight 301 accident shows pilot doesn't understand well with the automation, and accident occurred.
SOPs integrated with competence-based training and evidence-based training approaches will better address automation management. Automation can result in loss of situational awareness, and hence mental models must be continually refreshed through queuing, like calling out autopilot modes, for example entering GPS mode, alt mode, or vertical speed mode, and ensuring that it's part of the instrument flow, unlike AVIA3401. This allows monitoring over unexpected consequences of incorrect inputs. Also, the auto throttle system must be seen as part of the overall automation system, ensuring sufficient understanding of both the basis for the automation system functionality and its partial as well as full use. This helps avoid automation bias.
Today, aircraft have 3 types of automated warning system that aid pilot as well as ATC. Those that monitor the aircraft, for example, hydraulic system, pressurization system, electrical system, engine fuel conditions. Those that monitor environmental threats to the safety of the flight. For example, ground proximity warning system, wind shear warning system, and minimum safe altitude warning. Those that ensure the proper configuration of the aircraft by ensuring the aircraft is on its required phase. For example, landing gear warnings.
Automation can result in ambiguity due to inability to understand complex A and P mode, resulting in lost mental models. This may give rise to the probability of automation surprise. Normally, a high level of informed culture of system is required with modes, and hence to prevent ambiguity, like the auto throttle mode in AVIA3401 case. A mode control panel should be implemented with training and education to help comprehend this safety change. This will ensure appropriate feedbacks and interactions and avoiding over automations to deplete manual flying skills.